Okay, students, so we will be discussing today the last topic of the unit 1 sources of water, that is rainwater harvesting. So what is rainwater harvesting? Nowadays it is a most commonly used term in water resources. So it is a process of collecting, conveying and then storing the water from rainfall in an area in a particular area for the beneficial use, and the beneficial uses are of various types. We will discuss it afterwards. So in other words, we can say that the technology or the method used for collecting and storing the rainwater from maybe from tops, maybe from land surface or any catchment or watershed area, using various techniques such as tanks or check dam or recharge to aquifer. This runoff water, means the water which is flowing over the land surface or over the rooftop or any surface catchment area. This runoff water can either be stored or used further or recharged into the groundwater. So first option is, if we collect this runoff water mainly from rainfall, we have to store it first, and then according to our use, according to our need, we can use it, we can consume it further, or otherwise we can get it down in the recharge pit into the groundwater, so that the groundwater can recuperate or recover which we are pumping out or we are taking out for our need. Already we have seen in the well hydraulics in the last lecture that we are pumping out water for our need from the aquifer areas, may be confined, may be unconfined. So we have to, it is our responsibility that we have to recharge those groundwater quantity into the aquifer. So here is one option, rainwater harvesting. So we can store the water as a surface water in tanks or reservoirs, or otherwise as a groundwater we can store it in the underground tanks or any other structures. So why rainwater harvesting? It is a most promising alternative or option for supplying the fresh water in the context of increasing water scarcity and escalating demand. So with the passage of time, the demand is increasing day by day and water resources are going down. So we have to find out some alternative option. So here is an option. Rainwater harvesting gives a huge amount of water. Like we have considered a statistics, a fact that average rainfall of 1000 meter means rainfall depth is 1 meter. Average from this rainfall, if it happens, approximately 4 million liters of rainwater can be collected in a year. The time here is considered for a year, and the area is considered an acre of land, means 4047 square meter, over a 4047 square meter of area, and for 1 year we can collect 4 million liters of rainfall if the rainfall happens in average quantity or unit 1 meter. And it is the fact is fact also applicable that after the evaporation also, evaporation is a loss from any water resource or water body. So after evaporation also we can collect a huge amount of water through rainwater harvesting methods. As rainwater harvesting is neither so it is not a energy intensive method or technique nor labor intensive. It means that any type of power source is not needed, and also no labor or workers are not needed for the maintenance and to operate the rainwater harvesting technique or method. So it is obviously a cost effective option for water accruing method such as desalination of seawater and water transfer. So desalination of salty water or saline water or seawater and the water transfer is a very cost intensive method. So compared to that method, it is very cost effective option. With the water table falling rapidly, as we know that water resources and the water table under the ground are hugely decreasing, and with concrete buildings, paved car parks, business complexes, malls and landfill dumps for solid waste are taking places of water bodies, rainwater harvesting is the most reliable solution for augmenting groundwater, for increasing the groundwater level to attain self-sufficiency in public distribution of water. So it is a self-sufficient, self-sustainable method for beneficial use for us also. So purposes are majorly two: agricultural and human consumption. So first, if we can consider it for our need. So first is human consumption, and for agriculture and irrigation purpose also, that is also our need itself. So second, a major second purpose is agriculture or irrigation. Another purposes are freshwater augmentation technology, means freshwater increasing, augmentation means improvement technology. It increases groundwater recharge. We can recharge or recuperate or recover the groundwater table, which is decreasing day by day. Reduce the stormwater discharges. So if we collect that the rainwater or stormwater, it will, the quantity of stormwater as a wastewater will reduce, and urban floods then also reduce, and overloading of sewage treatment plant. So sewage, in the sewage treatment plant, the wastewater which we have to treat and purify and then dispose of, it will be less, the quantity of the wastewater will be less, so overloading will not happen. Reduce seawater intrusion in coastal areas. So if the stormwater is flowing down to the seawater during the heavy rainfall, the seawater will intrude or entered in the coastal areas, so it will also be reduced. So rainwater harvesting systems consist of following points: how it can be maintained. The basic components, or you can say the steps involved, are discussed here. First one is the catchment area. Catchment area means from where we are going to collect the rainfall quantity. So catchment for where water is captured and stored or can be recharged. Then is conveyance system. So in rooftop harvesting method, if we want to install and water harvesting, rainwater harvesting system in our house, so the rooftop will be our catchment area. In the left hand side, the diagram is shown here. Then a conveyance system is needed for carrying out the water harvested from the catchment area or rooftop area to the storage area or storage tank, or if we want to recharge it, to the recharge zone. So conveyance system means we need a downtake pipe from the rooftop, and if we want to store, to the one portion of the pipe will go to the rainwater tank or storage tank. And here it is the left hand side, in the left hand side diagram it is shown here. The tank is given here for storage facility, or if we want to recharge it, then for same, from the downtake pipe it will go to the recharge facility where we want to recharge. Then first flush, that is used to flush out the first spell of rain, because with the rainfall some of the dissolved particles, which some of the particles or pollutants we can say, will be in the air. So with the rain water droplets, that particulate matters will fall down to our catchment area or to our exposed surface. So first some quantity of the rainwater we have to flush it away before collecting. So it is known as first flush, that is used to flush out the first spell of rain. Then filter used to remove pollutants. Then we can use in the storage tank also, we can use filters for removing the extra pollutants that has not been flushed out or removed from the first spell of rain, or from the first flush system. And in the storage tank we have to get a storage tank or any various recharge structures. Various recharge structures we will see afterwards. You can check or refer this website, http rainwaterharvesting.org, for further reference. Now we are coming that the option for recharging the groundwater by the help of rainwater harvesting method. So groundwater is major sources for water supply in many parts of the world where surface water bodies or surface water resources are not in abundant quantity. Groundwater is being collected in aquifers over thousands of years through infiltration and groundwater flow recharge, that we have already seen in well hydraulics topics. A particular amount of groundwater is replenished, means recovered or recuperated regularly through the rainwater infiltration. Sustainable use of groundwater means withdrawal of groundwater at a rate at which it is replenished through recharge. So we have to focus or highlight the not only the use of groundwater to fulfill our demand, but with its sustainable use. So sustainable use of groundwater means at what rate we are withdrawing or pumping out the groundwater, with the same rate the groundwater should be replenished in the aquifer zone also. Faster withdrawal rates would lead, if we only focus to our demand, so faster withdrawal rate would lead to fall in water table level, and finally depletion of groundwater will happen. The groundwater recharge areas need to be identified so that maximum recharge can be achieved. So we have to identify the which area, in the which aquifer zone or which area for a particular city or for particular state, which areas we have to focus, or we have to identify, so that maximum recharge has to be done there. For that purpose, Government of India has constituted a board regarding groundwater. It named as Central Groundwater Board, CGWB, and its website is given here: http://cgwb.gov.in/groundwater. You can refer it for the groundwater recharge and recharge options. So there are multiple benefits, as we can see in the earlier slides. We have discussed also: improve in the quality of groundwater, rise in the water levels in the well and also in bore wells that are drying up, mitigation of the effects of drought and attainment of drought proofing. So drought can also be mitigated, it can be reduced also. An ideal solution to water problems in areas having inadequate water resource. Reduction in the soil erosion, as the surface runoff water is reduced. If we are collecting the rainwater, the runoff means the quantity of water that is flowing over the surface. So the surface runoff water quantity will be reduced, and it will also reduce the erosion effect of soil. Decreasing in the choking of storm water drains and flooding of roads. So if the surface runoff water quantity is reduced, then it will also reduce the flood effect or choking of storm water drain, means rainfall water drain. Saving of energy to lift groundwater. If 1 meter rise in the water level, if groundwater level is risen up in the aquifer, then we have to pump the power and the cost also we can save in the context of pumping. So it is given that 1 meter rise in the water level saves 0.4 kilowatt hour kWh of electricity. So electricity can be saved, and ultimately cost can be saved. So now we are going to the to different methodologies that we can used, or we can construct as per our convenience, for urban areas also and for rural areas. So for urban areas, there are rooftop rainwater harvesting method which we can use, we can install in our houses also. Through recharge pit, stormwater runoff harvesting through recharge pit, we will see how we can construct this pit or trench, tube well and recharge well. And for rural areas, through gully plug, contour band, gabion structure, percolation tank, check dam, maybe dug well recharge, groundwater dams, etc., etc. So first, by by recharge pit, we can harvest some rainwater. Like recharge pits are of any shape and any size. There are no fixed dimension. Are generally constructed 1 to 2 meter wide. Width is 1 to 2 meter, means breadth, and 2 to 3 meter deep. Length can be 3 meter on an average. So the pit is have to be dug, and these pits are backfilled with boulders and gravel, coarse sand in graded form. Boulders will be at the bottom, and which will be on a greater size, gravel in between, the coarse sand will be at the top, so that the silt content that will come with the runoff water will be deposited. So sand will be at the top, then the layer will be of gravel, and lastly of with boulders. The silt content or the particulate matter or particles which will come with the rainwater surface runoff, it will get it restricted in the first coarse sand layer, because the void spaces will be less. The technique is suitable for buildings having a roof area of 100 square meter. Next is recharge trench. Trenches are suitable for the buildings where the recharge area or the rooftop area is more to 100 to 300 square meter. The trench may be of width 0.5 to 1 meter and depth 1 meter to 1.5 meter, and will be long because it is a trench, shape is trench, so it will be long 10 to 20 meter long, depending upon the availability of water to be recharged. So as in the diagram you can see, the rainwater is collecting in the rooftop, and by the downtake pipe and this pipe, conduit pipe, horizontal conduit pipe, it is going to the recharge trench, which is already have dug out at the periphery of the area of the building or house. By existing tube well also we can recharge, like in areas where the aquifers are in shallow, and the means the depth is shallow and have dried up, and the existing tube wells are tapping deeper the aquifer. So existing well is at the deeper depth, and the shallow depth, in the shallow depth of the aquifer, which is already dried up. The rooftop rainwater harvesting through the existing tube well can be adopted to recharge the deep aquifers. So what is happening here also, it is written PVC pipes of 10 cm diameter are connected to roof water drains or downtake drain or pipes to collect the rainwater. So here it is that the downtake pipe is coming, collecting the rainwater from the rooftop area, and it is going to the first to a recharge pit of sand, gravel and boulder, and then it is connected to the recharge well. So all through the recharge well, the rainwater is going to the deeper aquifer depths. So by existing tube well also we can recharge the rainwater, we can recharge the aquifer by the help of water. In areas trench with recharge well, so in areas where the surface soil is impervious, so here soil is a factor. So the soil is impervious in nature, and large quantities of roof of water or surface runoff water is available within a very short period of heavy rainfall. The rainfall, what is the characteristics of the rainfall? The rainfall is intensity is heavy within a short period of time, and soil is impervious. So use of trench or pits is made to store the rainwater or surface runoff in a filter media and subsequently recharge to groundwater through specially constructed recharge well. So here not existing tube well, recharge well is specially constructed, and before that use of trench or pit should be there. Recharge well of 100 to 300 millimeter diameter is constructed to a depth of at least 3 to 5 meter below the water level, below the groundwater level. So it will go deep down to at least extra 3 to 5 meter below the groundwater level. The number of recharge wells in the trench can be decided on the basis of water availability and local vertical permeability of the rocks. So the number of recharge well which we have to construct will depend on the water availability and the vertical, because the water is going down, so vertical permeability of the rock. Why it is written here rock? Because the soil is impervious. So rock is also impervious in nature. So where there is a rocky geological formation, there also we can use trench or pit with recharge well. Now we are coming to gully plug for rural areas. So gully plugs are built using local stones, clay and bushes across small gullies and streams running down the hill slopes, carrying drainage to tiny catchment areas during rainy season. So the catchment, where the catchment area is less and there is the contour is not uniform, it is with downhill slope, upward and downward hill slope. So gully plugs are in this context, gully plugs are built, and this these plugs are built with local stones, clay and bushes. Gully plugs helps in conservation of soil also and moisture in the soil. The sites for gully plugs may be chosen whenever there is a local break in the slope, in the hill slope, to permit accumulation of adequate water behind the bunds. So the site suitable for the gully plugs may be chosen when the slope is with break. The slope is not continuous, where we can actually collect or accumulate the adequate runoff water which is coming from rainfall behind the bund. Bund or plug is of same meaning. Now contour bund. So the picture here is showing also the gully plug and the contour bund. So contour bund and plug is of same meaning. So the contour bund are suitable when there is a when the area is having a low rainfall areas, where monsoon runoff or rainfall water can be impounded by constructing bunds on the sloping ground all along the contour of equal elevation. So here it is written that the contour level is 500 meter maybe, and according to that contour line the bund is constructed. Spacing between two contour bunds depends on the slope of that area and the permeability of the soil. If the permeability of the soil is less, the close should be the spacing of the bunds. If permeability of soil will be less, then the runoff will be high. The quantity of runoff water will be high, and for that matter we can collect the huge amount. We have to collect actually a huge amount of rainfall water. So the spacing of the bund will be less or will be close. The spacing will be close. Contour bunds is suitable on the lands with moderate slopes without involving terracing. No breakup or terracing is needed in the contour bund. So here it is in the first at 550 contour level, some of the two gully plugs you can say is constructed, and it is shown here with the dark thick lines, and at 500 meter contour a total bund is constructed. The slopes are within towards the downward direction of the diagram. Now it is coming which is named as gabion structure. So this is a kind of check dam actually. It also means the restriction or bund or plugging. So this is a kind of check dam commonly constructed across a small stream, narrow stream, to conserve stream flows with practically no submergence beyond stream course. As you can see in the diagram, a small bund is constructed across the stream by using locally available boulders in a mesh of steel weirs and anchored to the stream banks. So here the stream is flowing according to the direction of the water. So with the flow of the stream across the stream path, a bund structure is constructed with locally available stones or boulders, and the boulders are fixed with steel wire mesh because we have to restrict the stream flow, and the boulders cannot get off from its place, and it is anchored with the stream banks also. The height of this structure is around 0.5 meter and is normally used in the stream with width not less than less than 10 meter. If the width is greater than 10 meter, then the structure will not be suitable here because the flow of the stream will be more than. So it is named as gabion. Now check dam or cement plug or nala bunds, almost same. The site selected should have sufficient thickness of permeable bed or weathered formation, geological formation, to facilitate the recharge of stored water within short time period. So first the site for constructing this check dam or cement plugs or nala bunds have some factors we should keep in mind, that there should be sufficient thickness of permeable strata. The water stored in the structures is mostly confined to the stream course, stream path, and the height is normally less than 2 meter. The check dam or the bund height is less than 2 meter, and excess water is allowed to flow over the wall. In Himachal also we have seen some check dams or nala bunds in some narrow streams or nalas actually, or in khads also. To harness the maximum runoff in the stream, series of such check dams can be constructed to have recharge on regional scale. So it means here that not only one check dam or one nala bund, series of nala bund can be constructed on the across the stream or nala or khad to harness the maximum runoff and to recharge on but regional scale on means local areas. We can construct the check dam and we can recharge the aquifer zone, and also we can take out the water stream runoff water on the back side of the check dam or nala bund. Now dug well recharge. So here dug well is constructed. The recharge water is guided through a pipe or conduit from desilting chamber to the bottom of the well or below the water level to avoid covering of bottom and entrapment of air bubbles into the aquifer. So here First, the water is conveyed through some pipes from the desilting chamber. So silty water is coming, and we have to construct a chamber or a basin where the silt is where the silt which is coming with the flow of water will be deposited and will be desilted. From the desilting chamber, with the help of pipe or conduit, delivery pipe, the water is going to the bottom of the well or below the water level, not actually bottom, below the water level, to avoid the scouring effect at the bottom of the well. Recharge water should be silt free, and for removing the silt contents, the runoff water should pass through either a desilting chamber or filter chamber. So this desilting chamber is shown on the left hand side, and otherwise the second option is filter chamber, where coarse sand and pebbles or gravels are filled with the filter chamber, and the water will flow through this filter media and get filtered to remove the silt content. Periodic chlorination should be done for controlling the bacteriological contaminations, because the with the rainfall water and the surface runoff, bacteriological contains or contamination or pollutants can happen. So periodical chlorination should be done in the dug well. Type of rainwater harvesting structure depends on the topography, maybe on hill slope or maybe on flat, on the stream path, availability on land, rainfall quantity or rainfall intensity, economic status, etc. So built up areas, for built up areas, temple tanks, rooftop harvesting method, wells, parking lot storage, recreational park ponds can be constructed on built up areas. And in open areas, percolation ponds, infiltration galleries, community wells, farm ponds, ducts, aqueducts across the streams can be constructed. So there is a huge potential in rainwater harvesting methods. Water yield from a catchment area depends on amount of rainfall, watershed slope, types of soil, maybe pervious, maybe low permeability with, or maybe with high permeability, maybe impervious, and vegetations and the evapotranspiration ratio. Evapotranspiration is a loss, actually combined effect of evaporation and transpiration from the vegetation. Vegetation management. Improved management of vegetation are mainly applicable to large areas. Water yield from the grass cover is more than from a forest cover. So on a land surface where a forest is actually there the water surface runoff water will be less, and when on a land surface which is covered with grass, the water yield will be more. Alteration of land surface of a catchment, may be pervious to impervious. The catchment area, the area in the catchment, the land surface should be altered or changed from pervious to impervious. Laying of paved surface on sloping catchment along with drains at their sides. Collection of catchment runoff in storage tanks. Method is preferable while the land surface is undulating. Where the land surface is on slope with uniform slope, the land surface can be made impervious to catch or to collect the rainwater by laying the paved surface on the sloped catchment area with their drains also, and collected into a storage tank. There are some hydrological aspects also. Hydrology means a study of water and its path, its intensity. Although there is a plenty of water on earth, it is not always in the right place at the right time and of right quantity and quality. So hydrology to understand the complex water system of the earth and help to resolve any water resource problem. So rainfall is the main source of hydrological cycle, and hydrological cycle means change in phase in hydrosphere. Balance of water on earth remains fairly constant over the time. Meteorological factors, type of precipitation, because rainfall is the main aspect, main important thing for rainwater harvesting technique, for any techniques or any methods. So type of precipitation, rainfall intensity, its amount, its duration, distribution of rainfall over the catchment area, direction of storm movement, precipitation that occurred earlier and resulting the soil moisture content. From there the surface runoff can also be changed or altered. So how much water can be harvested? So we have to calculate or estimate the quantity of rainfall, rainfall water. So the amount of water which is received in the form of rainfall over an catchment area is called the rainwater endowment of that area. So rainwater endowment is the total amount of water which is received. Out of this, the amount that can be effectively harvested, harvested means collected, conveyed and stored. So out of these, the amount that can be effectively harvested is called the water harvesting potential. Water harvesting potential equals to rainfall in millimeter area of catchment into the runoff coefficient. So area is, rainfall is the main thing, is the source, over the area of catchment, and it is multiplied by runoff coefficient. Or water harvesting potential can be written as rainfall into collection efficiency. The collection efficiency depends on the fact that all rainwater falling over the area cannot be effectively harvested, because some of the water will be get lost from evaporation or spillage. So the factors like runoff coefficient is to be considered here. So runoff coefficient means that it factors accounts that all the rainfall falling on a catchment area cannot be collected. Some rainfall will be lost from the catchment area by evaporation or retention on the surface itself. So runoff coefficient will vary from different catchment areas. Like if the roof catchment area with covered with tiles, the runoff coefficient will be 0.8 to 0.9. If it is metal sheets, 0.7 to 0.9. If it is ground surface but covered with concrete, 0.6 to 0.8. Brick pavement, it will be 0.5 to 0.6. Untreated, if untreated ground means natural ground catchment area, soil of on slopes less than 10% is 0.3 or maybe 0, and if rocky natural catchment, it will be 0.2 to 0.5. So it will depend that the land surface area maybe of natural ground, or with paved with concrete or paved surfaces, or maybe the catchment area will be roof with tiles or metal covered with metal sheets. So in the picture diagram, it is shown here that the area of catchment area in square meter into the amount of rainfall will be the volume of water received in cubic meter. Sorry, the flow chart here is shown for integrated rainwater harvesting in an area. What is shown here? Rainwater harvesting method is basically classified for built up areas and non-built up areas. Built up areas can be also for built up areas. It can be done, the rainwater harvesting, it can be done by direct use or to recharge the aquifer. For direct use, sumps are used or wells are used for storing the water, and the excess water can be conveyed to the recharge pit or trench, also to recharge the aquifer. And like this, groundwater recharge can be done. And for non-built up areas, we have seen that various recharge structures are constructed, like check dam, percolation pond, or gully plug or gabion structures, and these can also help to recharge the groundwater. And by the recharge of groundwater, we can use our we can use the water from the aquifer for our future purposes. And for more water resource information and water harvesting methods, refer the you can also refer the direct website, Ministry of Water Resources, Ministry of Jal Shakti, Department of Water Resources, RDNGR, http MOWR dot, it is dot government.in, or you can check the Facebook page. The link is shown here. Thank you.